Solving quadratic equations by factoring. So here we have an expression 6x square plus 2 is equal to negative 7w. It's in fact an equation because an equality sign. Some two terms are there on the left hand side and there is one term on the right hand side. And it appears to be quadratic because the degree is 2 and it is quadratic. So the first step to move forward is to write this equation in the standard form. We have to make sure that the given equation is in the standard form. You know that the standard form of a quadratic equation is ax square plus bx plus c is equal to 0. There is a 0 on the right hand side and you have ax square plus bx plus c on the left hand side. And after writing that in standard form, we have to find the factors, and after getting the factors, making use of the zero product property, you get two linear equations and then solve those two linear equations, and after that, if you want, you can verify your answer also. Okay, let's go. So to write this in standard form, I have to take away negative 7w, right? So how can I get rid of this negative 7w from the right hand side? Just by adding 7w, right? I'll add 7w on the right hand side. So if I add it on the right hand side, I have to add the same term on the left hand side also. So you added 7w on both sides. If you want, you can note it down here. Add 7w on both sides. Now what happened? This 7w, negative 7w, positive 7w, it got cancelled. Now what is left on the right hand side? We are left with 6w square. I'm just bringing down that 6w square plus 2 and then 7w. I cannot do anything with the 2 and 7w. You can't add them because 2 is a constant term and 7w is a term with a variable w. Okay, so you just bring down those two without adding. Just write down 7w. So I'm maintaining that order. 7w plus 2. Now you see, this is exactly in this form of a standard form of a quadratic equation. You have ax square plus bx plus c equal to 0. Instead of ax square, here you have 6w square. X is a variable in the standard form. There you have w. You are trying to find the value of w. Okay. So we transformed the given equation into this standard form. So go ahead and find the values of a, b and c. What is your a now? A is matching with c. 6. A is equal to 6. B is equal to 7. And c is equal to 2. Okay. So after writing in the standard form, I identify my values of a, b and c so that I can go find the factors, right? Now following the procedure, I'll find the product of a and c. So a times c is equal to 6 times 2. That gives you 12, right? Now 12 is the product of two factors or two numbers whose sum has to be 7. That I can represent in this way. My sum of 7. See, the b value is the sum, is the 7, and the product is a 12. So I need two numbers whose sum, when you add those two numbers, it must give us 7, and multiplication of those two numbers should give you 12. So what are those? 12 is a small number, and you know 6 and 2 won't work because 6 plus 2 is 8. Other option is 3 and 4. Look, 3 times 4 is 12 and 3 plus 4 is 7. So we are good. And like I said, always we'll try to have the greater number first. It's not necessary, but I'll write down this bigger number first and the smaller next. And also please remember, this identification of two numbers is the most important part of solving a quadratic equation. Getting those two numbers whose sum is something and the product, it has to satisfy those two conditions. Adding gives you 7, multiplication giving 12. Now we will write this equation 6w square plus 7w plus 2 as 6w square. Instead of 7w, I'll write 4 plus 3. That is 4w plus 3w. And the last term here, I have 2. So I'll write down 2. And what is left on the right hand side? That is 0. Okay. So you see, 6w square plus 7w is broken down as 4w plus 3w. 4 plus 3. And the last term is 2. Now, like we always do, if you can draw a square. So in this rectangular box, we will enter our 4 terms. 6w square. Okay. So I have entered the 6w square plus 4w and 3w plus 2 in these 4 boxes. Now look for the common factors both horizontally and vertically. That will go in the rows and then columns also, and we will look for those common factors. Now between 6 and 4, what is the greatest common factor? 6 is an even number, 4 is also even number, 2 divides, and 2 is the greatest number that can divide those two. So I'll write 2. Okay, 2 is the common factor. 2 here, and also I'm saying w square and w, therefore 2w is a common factor, right? Between 6w square and 4w, not only this number 2, but also w comes out. Now from 6w square, we have taken off 2w. So what is left over? 6 divided 2 is 3 here, and w square over w is just w. So 3w is left. I'm writing it over there. Now look, 2w times 3w is 6w square. Now, so do the same thing here. From 4w, take away 2w, gives you w cancel off. You are left with 2. 4 divided 2 is 2. So 4w is written as 2w times 2. Check it out. 2w times 2 is 4w only. We didn't change anything. Now similarly, next row, I have 3w and 2. What is the common factor between 3 and 2? They are co-prime. That is, there is no common factor between those two. When nothing is existing, take 1. 1 is the common factor. Make use of 1, and here w, and there is no w also. Just 1 is the common factor between these two terms. So 1 times 3w, and in this also I'll write just 1 times 2. 1 times 2 is 2 only. Alright. Now after doing this, I'll look for the common factors horizontally. That is 2w. I'm seeing in these two boxes. So that 2w comes out, and between this next row, I see 1 and 1. So I'll take out that 1. And what happened there? Here, see, we are done with the rows. Once you are done with the rows, go to the columns. That is the vertical one. I'm looking at 3w. in both these columns, both the boxes of the first column, I should say. So 3W here is out, and 2 and 2. See, that is taken out. Now you can see that the 2W's are gone and 3W is gone there. Same way this 2W and 2 is gone. 1 and 3W, 1 and 2. Everything is taken care of. And we ended up getting the factors of the given quadratic equation, right? So I'll write down the factors. The first one here, the top I can write first, that is 3W plus 2. 3W plus 2 times W plus 2 times 2W plus 1. So we got here 3W plus 2 times 2W plus 1 is equal to 0. So these two are the factors of the given expression. Like we have there 6W square plus 2 is equal to negative 7W is written in standard form, and we followed that process, ended up getting these two factors. What? 3W plus 2 times 2W plus 1. Now using that property, zero product property, we'll find the value of this variable W. So the first one is, I have 3W plus 2 is equal to 0, comma 2W plus 1 is equal to 0. So that quadratic now changed into two linear equations, and we have to solve those two. To cancel out 2 from the left hand side, I will subtract 2, taking away 2 and 2, you got 3W plus 2 minus 2 cancel off is equal to negative 2. And so if 3W is equal to negative 2, to find W or make W by itself, by dividing it with 3. So on dividing by 3 on both sides, you got W is equal to negative 2 over 3. That's the first thing. And in the second equation, 2W plus 1 equal to 0. So take away 1 on both sides. You have 2W, bring it down. 2W, 1 and 1 cancelled off, positive 1, negative 1. 0 minus 1 is a negative 1. Then to make W by itself, I'll divide by 2 here. There also divide by 2, leaving behind W is equal to negative 1/2. Because of this cancellation, you got W is equal to 1/2. So these are the two answers. W is equal to negative 2/3 and W is equal to negative 1/2. So my answer or the solution to that quadratic is W is equal to negative 2 over 3, comma, negative 1/2. Okay, then further we can verify our result by substituting these values of W in the given quadratic equation. This is the one they gave it to us, right? At the beginning, 6W squared plus 2 is equal to negative 7W. So let me substitute the first value of W here in this, and see 6 times W is how much? Negative 2 over 3. I'm plugging in or substituting negative 2/3 square plus 2. is equal to negative 7 times W is what? The value of the W here is negative 2/3. Okay. Now let us find this left hand side and right hand side and verify if those two numbers are equal. Okay. We'll make use of our calculator. I have here 6. Okay. 6 times negative 2 divided 3 whole square, then plus 2. That gives you how much? It's 4 point something 666. I'll change it to fraction. Okay, 14/3. I'll write down here that's 14 divided 3. 14/3. And on the right hand side, you see 7 times 2. The numerator 7 and 2. 7 times 2 is 14 and 14 divided 3. Negative times negative is positive. So 14/3 is equal to 14/3. It is true. Hence this answer negative 2/3 is correct. Let me show that piece in calculator. It is negative 7 times, or just I can write parenthesis, times negative 2 divide 3, close the parenthesis. See, it is the same number 4.66. Further change it into fraction, that same 14/3. Okay, right, this part is done. Similarly, you can substitute negative 1/2 here. 6 times negative 1/2 whole square plus 2 must be equal to negative 7 times negative 1/2. That you can try. Alright, now I also have two problems for you to try. Okay, following the same process. The first one is this, and the second you have there. Now to answer this first problem, we just have to write it in the standard form. Because of the negative 15W, add 15W on both sides, bring it into the standard form, and following the same steps like we did for the example problem. So you can just find the value of x, that is, solve it for W in this case. Okay, the next one is 5W square minus 24 is equal to 26W. We have to get rid of this 26W from the right hand side. You can do it by subtracting this on both sides and bringing it into the standard form and solving it. Okay, please try to answer these two problems. Okay, thank you.